And welcome back. This is the traditional video for end of the year where I talk about things, and 2022 has been a year of many things. This year has been the point where the time demand for my own shop and the time demand for my day job conflict each other. And this has proven to be extremely stressful, and also you notice that in a result in a lack of videos, in a great lack of. I tried to do at least the one video per month schedule that I put onto myself, but apart from that there were not too many additional videos, and I want to get better on that. Well, I say that all the time, but I really try. And the stress of running basically a day job and my own shop has gotten me to the decision to take a 1-year sabbatical from my day job. Means that I can stay at home for 1 year and do whatever I want. I will use that year, apart from 1 month. I will be 1 month in New Zealand on vacation, which is very exciting for me because I have never been to another continent nor flown in an airplane. So that's going to be extremely exciting for me. Don't worry, this channel is not becoming a travel adventure channel. This is going to stay a machining and manufacturing channel. The remaining 11 months will be used to get this shop in line, to get my own operation in line and see how it works out if I run it as a full-time business. And then I will see if I'm going back to my day job or become a cave dweller here in my own shop. It's not only the business side of running a shop on a sole basis, but also the mental thing. You're in here for many hours alone, and there is a high chance of becoming a hermit, so to speak, and losing your mind when you work all day alone and you only have the podcasts and radio to listen to. There is a need for social interaction for most of us. There are people who can live without any social interaction, but I have a need for social interaction, and I will see how that works out. Also, I'm going to miss my co-workers. They are a great bunch of people. These are the best people I've ever worked with. Well, I work as a special machine builder. We build production equipment and automation equipment, and we're basically doing everything. We build the machine frames when they are not welded. Welded frames get manufactured somewhere else and then brought in. But if it's aluminum frame, we build it ourselves. We assemble all the machine parts. We do small machining operations ourselves. We set up all the sensoric and the pneumatics. We build the electric cabinets. We do pretty much everything from start to finish to build a machine and then put it into production. We rig the machines ourselves, we move them in place, we set them up, well, there is nobody else who does it, so we have to do it. And I'm kind of going to miss it and not going to miss it. It's extremely stressful when you get to a point where you have the machine finished and it's not running as it should be. When there are problems that nobody expected. That's the stressful part, and that's the part where you need to spend hours and hours and hours of troubleshooting, and that's time that I lose working in my own shop. So that's the reason why I'm going to stay at home for a year. Which brings me also to the point of Patreon. There is the possibility to support this content creation that I do, the video creation, via Patreon. And now somebody might say, well, you already get money from YouTube AdSense. That's true. That's the advertisement money. I don't put advertisement in the middle of the videos. I absolutely don't do that. I think I have pre-roll and post-roll advertisement, and they should be all skippable. So I don't do the full advertisement that cannot be skipped and needs to be run for at least 30 seconds. I don't do that. And the YouTube money that comes out there is well, it covers the absolute base costs of the shop of consumables, which I'm very grateful for. It's money. Then there is the argument that I'm already making money off the customer parts that I'm making in here. Yes, that's true. That's the hourly rate that I charge to work on customer parts. But then there is the time that I spend filming, editing, doing voiceover for the videos on, for example, said parts. And that goes away from the time that I have to work on customer parts. And long story short, I consider the Patreon money basically a voluntary wage for my video editing. I don't know if this sounds arrogant or not, but it's really helping me out. It gives me the possibility to take on a little bit less work from customers and spend a little bit more time on editing. And I try to get my videos out in a decent, polished manner. I try to do a good job on the editing, video quality, framing and stuff like that. I try to do a decent job on the audio. I know that my audio is not always flawless. It's far from flawless, and there is a lot that I need to learn on audio editing, but I try to get better. So there's that. Thank you for all that support me via Patreon. And also, there is one thing that I want to mention. I will never, 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 ever do a paywall. I will never do content that can only be accessed by paying me. My content side will always be free. I will never charge money for it. The Patreon money basically helps me to keep at least a little bit denser spacing between the videos that I upload and edit. So that's that. Enough money talk. If you want to support me, if you want to help me out that way for the video side, link is down there somewhere. If not, that's totally fine. Cost of living increase for every one of us at the moment. It's a tough time, and I fully understand if people pull out of Patreon too. I'm not holding a grudge against anyone who says keeping my home warm is more important than throwing money to this goofball doing stuff on YouTube. So that's that. I think that's all I have to tell about that. Let's do a shop tour with the current condition of the shop and see how things are going. So I replaced the old door. I put in a completely new door because the old one was about the thickness of a yogurt container, and this is a proper house entrance door. So way nicer. In general, just a better door, well insulated, good thing. From the entrance we have the Deckel FP1 mill with the overhead crane for the heavier accessories, like the rigid table, which sits here under this rack on a furniture dolly, or the slotting head, that's the blue rack back there, also sitting on a furniture dolly. Having those pieces on rolling carts is very nice to move them out and lift them with the crane onto the milling machine. Milling machine with all the major work holding accessories like large parallels, magnetic plate, different vices. The chuck is mounted. I have my 40 taper tooling here on a wooden rack. We can look at that close up. So we have a little rack here with 40 taper tooling with the S20x2 pull stud for the Deckel mill. We have a hydraulic chuck, which I try to use as a quick change solution because the hydraulic chuck just needs a few turns here with an hex key to change tools. And that's a very nice solution if you want to change tools with the tool holder still in the spindle and don't want to change the complete holder. If you use a lot of same diameter shanked tooling, this seems to be a nice solution, because you can keep this in the spindle and you just change the tooling, and in an extreme case you can change the sleeve. These are straight OD and ID sleeves to reduce down from the major diameter of this chuck, which is in this case 12 millimeter. There are also 20 and 25 millimeter hydraulic chucks down to 3, 4, 6 or 8 millimeter. So that's quite a nice tool. They are horrendous expensive. I think it's 200 and something euros. So not really needed, but I wanted to try it out, and it run out and stiffness is extremely nice. Morse taper 2 to 40 taper shank adapter. Currently holding my rotor broach holder for the rotor broaches. 40 taper drill chuck. 40 taper, this is shell mill arbor with a wheel cutter mounted on it. Long shell mill arbor with a small face mill. Woolhopter UPA3 boring head. Weld-on or side lock type tool holders. Another shell mill arbor with a shell mill on it. Morse taper 1 sleeve, and these are 40 taper direct clamping collets. These are very nice for larger tools like this big ass end mill. Then we have this monstrosity of a cabinet. As you can see, we have parallels here. These parallels used to be double the length. I took them and cut them apart on the surface grinder in half. So I have 4 of them each, four parallels, exactly the same dimensions, which is very useful, especially if you run the CNC mill with multiple vices on it. Thin parallels made out of spring steel, different parallels here, box with the sleeves. Random end mills, these are just boards with holes in it and end mills stuck into it. All these are used, but in a condition that doesn't allow me to throw them out, but I keep them around for quick and dirty work. Angle plate, prism, magnetic chuck, small 4-jaw chuck, large grinding vise, which I use on the Deckel FP1. A setup cube. This is modeled after Tom Lipton. It's welded together from 2 plates and a piece of heavy-duty square tubing, and then I think I did it on the shaper when I still had the machine, and recently I surface ground it. It's sometimes useful as a setup helper on the mill. Different pieces of plate stock just to aid in setups. Large angle plate, another grinding vise, self-centering vise up here with all of the quick change jaws. Moore 1, 2, 3 blocks, the smaller Moore setup blocks. I have a pair of huge heavy-duty parallels up here. I bought these from my day job. Somebody embedded some magnets and ground this flush, so when you put them on the machine table they don't slide around. Not the best idea in my mind. The magnets attract too much dust. Out here we have the important accessories for the mill. We have the Heimer's 3D probe, a dial test indicator in my shop built holder. This is a jig bore dial test indicator holder with the face vertical, so you don't need a mirror when you spin it. Very useful. 2 edge finders, place for 2 40 taper collet sleeves to use these small 355E style collets in the spindle of the mill. Why do I need 2? Because one goes in the spindle and one goes, for example, in the indexing head. Hand tools to run the milling machine, all the wrenches, soft-faced, what's this, rawhide mallet, the drawbar for the indexing head to use collets, 40 taper, spindle wiper, and some larger wrenches. Yeah, and on every machine I keep 3 bottles. I have some spare collets back here. Water-soluble coolant. I have cutting oil. This is Yokish Alpha 93 cutting oil, and some IPA, which is isopropane alcohol, not the hipster beer. So that's what I keep around the milling machine, and here is the cover for the horizontal spindle when the vertical head is not on the mill. So continuing on from the milling machine, we have the Emco Super11 lathe back there. So let's have a look at the setup over here. So we have the lathe. There is nothing new on the machine. Currently I have the compound slide mounted back here. Usual crap on the headstock of the machine. I have an indicator base here, a flashlight that I need sometimes. Air hose is right in arm's reach. That's the reason why I keep the tailstock on the machine. Wrenches to run the machine. I have my torque wrenches for my insert tooling. Normal Torx drivers also for changing tooling on insert tooling. A small adding permanent marker, wrench to change chuck, the multi-fix tool post wrench, and this one is for to set the run out on my 6-jaw chuck. I keep all my multi-fix tooling back here on these two shelves. It's kinda the lower ones all are for ID work, and the upper row here is mostly OD work. As you can see, I have something about almost 30 of these tool holders, and I still change them around all the time. Up here I keep my drill indices from 1 to 10 millimeters in 0.1 millimeter increment. These are general purpose. These are not, I grind these if necessary on the bench grinder or on a belt sander. They are not my precision first choice. These also go in a cordless drill if necessary. I have some countersinks, counterbores, reamers, this is an odds and ends corner. I'm not very happy how this is laid out currently, but time will tell. Machine light, I like these IKEA lights here a lot because they're very flexible and they kind of look like a machine light. Same bottle setup back here. Water-soluble oil or water-soluble coolant, cutting oil, and IPA. Digital readout, Icron. I like these a lot. And up there, this is again a odds and ends shelf. I have a box with my carbide drills. Scotch-Brite wheel, which can go in the lathe if I do polishing. I keep some of my oils and cutting oils and a bottle of soluble coolant up there, my hot plate, and a hot steel welder for plastic bags. I do some parts that need a welded bag for shipping. Also, I collect and separate chips if possible. I keep two smaller containers. One is for brass here, and the other one is for Neusilber, which is a nickel brass, or German silver is also a name for it. Very nice material. The chips of the Neusilber are almost worthless. Brass chips are rather expensive. Well, there is the window out to my hometown. I keep one or two plants around in the shop. It's nice not to be in a dead man's world. Since I don't have a sink in the shop, which if you ever build a shop yourself, make sure it has a sink. So I keep these hand cleaning wet wipes around. Set of hex keys. For some reason I have a hand sledge. I use that all the time. And From a workflow standpoint, when I'm working here on the lathe and I'm changing tools back and forth, I will usually pre-stage the tool. I'm doing a job where I need, for example, 5 or 6 tools, and I will lay them out here on the window and change them over to the lathe, do my work, go back, take the other tool, and it's basically, this is my this is my tool changer rest if I was a CNC machine. So I'm the tool changer here. So tool go here, tool go back until the job is done, and then they go back into the shelf over here. That's my workflow here. I have these huge large tin cans for sauerkraut, and I use these for scrap. This is mixed scrap, and this is another one that I keep separate, aluminum chips. I sort my aluminum chip. I keep my aluminum chips separately because I can sell them reasonably well. Same for the brass and nickel silver. So here we have the Deckel FP1 table under this rack on a furniture dolly, my Birkenstocks when I go into the house so I don't carry chips into the house. My general shop shoes are Crocs. These are really nice, very comfortable. Usually I don't need steel-toed boots when I work in here because I don't work with very heavy stuff. I keep my 2 main chucks out here, 5C collet chuck and the 6 jaw. This drawer cabinet is work in progress. I keep, for example, end mills, dbits, new end mills, which is a whole other mess in here. You see there are some without a cover, there are packages of new end mills. In here I keep my wheel cutters and gear cutters, face mill, ball end mills in different diameters. This is all not very organized, to be honest. I keep a sacrificial set of gauge blocks in here, a box of more sacrificial gauge blocks in here, and my angle blocks to do angled setups. Also, this was an experiment for a quill hand wheel, 3D printed for the Deckel FP1. Looks like a valve hand wheel. Works okay, looks stupid. And since I don't have a good place for them, I keep a ton of large end mills down here in this drawer. So this is my drawer of shame. So that's that. So this is below the lathe. This is another drawer of shame. I could pretty much get rid of all of this in here. This is more important. These are collet sleeve for a boring bar holder, floating reamer holder. This is my tapping guide, or not tapping, threading die guide. This goes in a boring bar holder, and then you have length adjustment, but it takes the torque from threading. I have holders with all the regular dies from M3 all the way up to M10. So I only changed this front piece. I have a bunch of hole saws. I don't use these hole saws very much, but they come in handy. I have my soft jaws over here. I don't use very much soft jaws, but when I do, they are very nice. The pneumatic drill chuck for the lathe, if I need a very strong holding drill chuck. And the lower one holds my Kress router spindle in a separate multi-fix holder if I do milling work on the lathe. A draw tube for collets, a hollow spindle, backstop. This is a commercial item. It works by 2 cones expanding these 3 sleeves out. Some wrenches, a knurling tool, the original four tool post of the Emco lathe, and something that I barely used, the carriage stop of this lathe. I think I never used it, in fact. This small wooden thing that I built when I was thinking that woodworking is cool holds custom ground lathe tooling. For example, a 15-degree chamfer tool, or a 56-degree chamfer tool, or, well, that's a lot of chamfering, a 0.5mm grooving tool, 2mm OD radius, things like that. Just custom ground tooling. Back there are some larger. Here, this is a mess, and this is also a mess. These are mostly reducer sleeve for boring tools, for round boring tools. Back there are some threading tools. Next to it I keep my files that I use on a lathe. This is a proper lathe file with a 45-degree cut, triangular file, large, small flat file, and a needle file flat with these exceptionally nice handles. And back there, another sauerkraut container. And since I'm very pressed for place, I keep, for example, two very large parallels here. These are 400mm long parallel surface ground. Sometimes useful for large setups on the mill. I used them at least once, and they were a lifesaver. This is one of those cheap fold-it-yourself IKEA sheet metal drawer cabinets. They cost like $40 or something like that, and they are really okay. And I keep all my small offcuts in here. Plastic, aluminium, tool steel. Well, it's drill rod and tool steel. Down there is copper and brass, and also some copper wire, solid copper wire. Stainless steel and regular steel. And down here we have some special materials like German brass. I have some mold release in here, just random bits and bobs. So then we have the ever giant workbench. I like to have a workbench in the shop where I can sit down, do sketching, and work on parts. Microscope, very important for me to have. I have this, I built this microscope stand. I did a video on it, and that's what I'm using. I have it bolted to the bench, and I basically just swing it in if I need it, and if I don't, I swing it all the way back to the wall and keep it like that. Usually there is a medium amount of chaos here on the bench, but I try to keep it kind of clutter-free in this general area where I want to work. Up here there are consumables that I use all the time, like Loctite, super glue, some oils, some solvents, soldering station. Over here I have just a little bit of a tooling out at direct disposal. Miniature bolt cutter, Nipex, wrench pliers. The one file that I use the most, a number 2 cut flat file. Usually there should be a triangular scraper, and there should be a knife, scissors, and one set of open-ended wrenches. Not very much tool. I don't use it. I see these shops with a ton of hand tools, and I'm questioning myself all the time, what are they using 5 sets of ratchets for in a machine shop? We're not mechanics, so I try to keep the stuff to a minimum. The miniature bolt cutter is nice to cut, for example, small stock to a rough length, round stock that is. I keep this is rather nice. This is a set of Vera. This is a a bit ratchet and a low profile ratchet for the socket set. I keep this at hand because sometimes I need to take apart stuff. Normal ratchet set, 1/4 inch. And up here it starts to get a little bit washed out what we have here. I keep my NSK micromotor for deburring, polishing and things like that. Right here, because I use it about 15 times a day. These are really nice. This is like a Dremel on steroids. Quick change tooling and 40,000 RPMs. Goes down to 1,000 RPM if you want. And in this general area up here, I keep, for example, open projects that I'm working on. Like, I keep, for example, my stones here that I'm grinding. I keep some of the projects that I'm working on, like Toolmaker's Cube. This is a little bit of a mess. Scotch-Brite sanding paper. Further up, tooling catalog. I keep some documentation on my machines. Encyclopedia of Machine Shop Practice, which a viewer sent me as a really nice gift. I keep 2 large boxes up there, which just contain more boxes. I use these mostly for shipping. These are, for example, end mill boxes. And I have these Rocco Handy Box. These are relatively nice. I keep some consumables in here, like high-speed steel punches and dowel pins or wiring material. So I keep, for example, all my wiring material here, like ferrules, spade connectors, and the ever mighty Vago Quick Connect clamp. This is the proper way to do wiring. You open this lever, you insert your wire, and you snap it in place, and that's a sound, safe connection. We have them in 3-pin and 5-pin connection, and I have a different style here which takes 8 wires if necessary. Also, I keep a little bit of dowel pins at hand, and these things here, roll pins. And this last one, this contains high-speed steel punches. These are just high-speed steel punches with a 60-degree tapered head. Normally these are used to build punch tooling. They're a standard item. You can buy them for reasonable little money, and you can make them in anything that you want that needs to be hardened. And they are fairly precise on OD. So, and the fourth of these boxes keeps, for example, springs, ball handles, ball knobs, some sinter bronze bushings, split collars, drill bushings, fine threaded nuts, lure lock needles, which I use a lot on syringes, and some knurled nuts and threaded inserts in different styles. As you can see, I don't stock too much crap in the shop. I try to keep it to a minimum because I don't know what I need anyways. I'm constantly buying different things. So that's the shelf. Crap down here, I keep my 10 liter oxygen bottle here, surface plate, Speaking of the surface plate, I purchased something. Unfortunately, I had to purchase it and nobody wanted to sponsor me, so I bought myself a Tesa height gauge, which is a fairly accurate or highly accurate height gauge. Once it arrives here, I will do a little bit of a show and tell on it if people are interested. Hey, it's Stefan from the future. Look what came in. Tesa height surface gauge. As I mentioned, I ordered this and it arrived today. Did you know that these come on a Euro pallet? I didn't. It's a massive instrument. It's very heavy, but it has an air pump inside and 3 air bearings that lift it off the surface plate and move it around. The air bearing is only for moving it. You do not measure while it's on the air bearing. That's not a precision air bearing. And what it is, it's a height gauge. The carriage moves up and down via a hand crank. And the carriage here is spring-loaded for a constant measuring force. And the most basic measurement that this does is height. Well, everything that this thing is height. You can go onto a surface plate, take the surface plate as a reference, and then you can check things for height, like this gauge block. It's a 30mm gauge block. This instrument is repeatable to 2 microns, so there is an uncertainty of 2 microns maximum. But in practice, it's really darn close. There's a 50mm gauge block, 50.001. What this also can do is, compared to a normal standard height gauge that you would use for scribing on a surface plate and maybe put an indicator in it, this can measure in both directions. And for that, we have a probe with a ball diameter. The ball diameter is not important because we calibrate it against the ball diameter. We go here, here, then this setup gauge here comes with the instrument, and you just probe down, and up. You do it twice, and then the instrument knows the diameter of the ball and how much the shank of the probe deflects. And then we can do things like a ring gauge. We need one reference surface, for example, a flat plane below that we need. And then we bring this in contact. We have a fine feed here that moves the carriage up and down, and over here on the display there is a bar graph on the side. This shows the measurement force. It should be somewhere here in the middle. Bring it in contact, then we slide the ring gauge past the lower dead center height, and it beeps again. That means it found the lowest spot of the bore in here and memorized that point. Now we move the probe up, bring it in contact until our measuring force is reasonable, and move it over. Beeps when it finds top dead center. Then we release it. Then it shows 17.003 millimeters. And now let's have a look what this ring gauge is. This is 17.003 millimeters. So that's bang on. So that's the Tesa height. It can do height of the surface plate, it can do distance between holes, it can do flat to hole or hole to flat. That's basically most of the function. And it's also a sliding squareness gauge. You can remove the probe, you put an indicator in. The column on this one is 5 microns square to the surface plate according to a test report. Means you can put an indicator here, you put your part here that you want to check for squareness, then you just crank the indicator up and down, reading against the part you're checking. So this is really a super neat, honestly very expensive instrument that I'm very happy to have at my disposal now, because I get more and more parts that need very reliable and also quick inspection. Building gauge block stacks with a small set of gauge blocks that you will see later gets odd very fast. So let's go back to the shop tour. But apart from that, 640 by 400 millimeter surface plate. I was considering getting a smaller surface plate, to be honest, because my shop is so small and I don't really do machine rebuilding anymore. But now with the Tesa height coming in, which has a fairly massive footprint, I think I'm going to stick with the 640 by 400. Currently this sits on a tool cart. I will remove the wheels of this thing and put on machine feet, because this is too wobbly to support or to properly do metrology on it. So if you wonder, this is just a stack of boxes, not folded yet. And in here I keep drills. I have drills up to 6.5 millimeters in 0.1 millimeter increments, and then it falls apart because I don't use large drills much. PCB drills, I buy them in packs of 10 because they're reasonably inexpensive, and they're very useful because they drill spot on size. If you drill a 2 millimeter hole with one of these, with a 2 millimeter drill, it will come out at 1.9999. Ever so slightly undersized, very precise hole. Tabs from M2 up to M12, and all the weirdo fine thread, left hand, UNF, UNC, MPT, and G threads, and some large fine thread tabs. Tab handle, die handles. This is die grinder tooling, burrs, stones, diamond, soft rubber abrasives, roll-lock discs for the large right angle 90-degree die grinder. These are nice because they are very fast to change. You can change to a bristle wheel or to a sanding wheel within a second. Stones, somewhere I have, these are CBN for doing steel. Insert tooling. I keep my inserts here. Some spare insert boring bars and OD turning tools and mill tools, and all my inserts. It's not organized. I just take the box when it comes in from ordering, and I write on it what it is. This is an SCMT insert for steel with a 0.4 millimeter radius. And when we have a look in the box, that's exactly what's in here. So in the beginning I tried to keep my variance of insert as low as possible, but I found that to be extremely limiting if you try to run production. At this point in time I just, well, if there is a tool I need and it has a different style of inserts, well, that's another type of insert in my shop. Some inserted mill tooling, a large chamfer mill, a PH horn grooving or slotting and mill with a interchangeable head. This is very nice. It shouldn't be in here because it bangs against each other. Also I keep spares like insert screws here, broken inserts, spare PH horn tooling, and some of the wrenches that comes with the tools. Down here we have some metrology. These are gauge block holders to build your own gauges with gauge blocks. Gauge block set. These are some 45 angles that I made long ago. These are highly precise, matched pair. I keep a Morse taper 2 a test bar in here. Straight plug gauges from 2 to something like 20 millimeters, I think. Yes, this is 20 millimeters. Thread gauges, ring gauges for threads. I have some weird ass thread gauges. I have a M4 by 0.35 millimeter gauge ring, or a M9 by 0.5 millimeter, or a, okay, this is standard thread, this is a G thread. I have a M28 by 1 fine thread ring gauge. Things like that. Rather weird stuff. Or this one is also, this is a good one. This is M13 by 0.5 millimeter. This is really strange. There are some pins, assorted pins. This is just a piece of carbide that I checked with the micrometer and used as a gauge pin. So I wrote the actual diameter on here with label maker. This is a 13.997 millimeter pin, which is very useful to gauge a 14 millimeter hole. Or this is a high-speed steel punch that I micrometered out. 10.996 is 11 millimeters practically. Things like that. I keep that around. Thread gauges, some these are radius gauges, concave and convex, and this is a taking apart feeler gauge. I prefer to take them apart and then I bend a holder like this that I can open up and remove individual leaves if I need to. Air die grinder, a planetary grinding spindle. I will do a separate video on this because it's a rather cool item. This is used for jig grinding. This is a micrometer checking set, which comes with a plan glass with a optical flat and some carbide gauge blocks. It's used to check micrometers. And in here there is a large precision square, not in calibration anymore. And down here we have a Woolhopter UPA1 boring head, which randomly sits in here. Okay, that's the overview of the manual department of my shop. It's getting dark outside. It's the 25th of December 2022, so first day of Christmas. And let's go into the CNC and grinding department over there. So let's turn on the light. So in here, this is the side of the shop that gets the most dirt. So this is the hallway through from the manual department over here in the CNC department. Department makes the sound way more legit than it is. This is just another room with a hole in the wall. There was a point in my life where I decided that I need a big drill press because I never had a big drill press, and I always had access to a big drill press at my day job. And we always used big drill presses, so I purchased this Optimum DH40GP, which is a geared head drill press. It uses the same head as my old Optimum MB4 drill milling machine that I had. I added a Mitutoyo indicator that I sliced apart on the surface grinder with a cutoff wheel, put it on here to give me a depth readout, engraved a new front panel, changed the handles, nice drill chuck. That's pretty much all the modifications that I did to it. It goes from 95 to 3,200 RPM, which is a very nice speed range, and since it's a gearhead machine, changing speeds from very slow to very fast is a very quick changeover. Most of the time it's enough to switch low and high or motor setting 1 or 2. It's a 400 volt or 3-phase 400 volt machine, of course, like pretty much any machine that I have at this point in my life. I don't keep much around this drill press. I like a set of countersinks in arm's reach, water-soluble oil, and some cutting oil for tapping. So it's a drill press. It's a very nice drill press, to be honest. You can, since this machine has a drawbar, you can put a collet chuck in here, a XY table on here, and you can do milling without a problem. Not very heavy duty, but you can do milling. We have a quill lock, which most drill presses don't have. And also, when I go over here, we also have a fine down feed, which is very nice. And also we have a power feed. Let's run this machine at a low speed. I will show you the power feed. As you can see, now it's power feeding. So that's very nice. It's more drill press than I need really, but I wanted to buy one drill press and never be bothered again by it. And people told me that it would be better to get a very good old Altsmetall drill press made in Germany, blah, blah, blah. And I kind of agree and I kind of disagree. Yes, an Altsmetall drill press is better quality than this one, but this one has... We have a bunch of Altsmetall drill presses at my day job. I'm very familiar with them. They are very good machines, but this machine is more versatile. I can put a boring head in here, mount it with the drawbar and be very secure, and do boring with this machine. I can bore a very large part on this. You can't do that on the same size Altsmetall drill press because they don't have a drawbar, and things like that. And also, I dislike the design of the Altsmetall with the motor hanging off the back and making it a very deep machine, since on this machine the motor sits up on top. So there is very much reasoning behind why I choose this machine. Going to the right of the drill press, this is, by the way, how a 400 volt outlet looks here in Germany. These are Secon connectors. There are 5 pin, 3 phases, neutral and ground. And these are 16 amp rated. The ones I bought here also have a 230 outlet up here, which is very nice because when you're already doing wiring, you get a free 230 outlet too. This up here, this is a product of my employer. Well, it used to be a product. I think these are about 20 years old. This is an infrared switching relay. Basically, it has an outlet here, and it plugs itself into an outlet. And you have either, this is a wall transmitter, they are made also a handheld transmitter. And I use this to run the shop vacuum here. That's very nice. I put a big honking magnet on the back so I can stick it on a machine when I don't need it or when I want to keep it in place. So right here I keep a little bit of setup tool for the drill press, like this copal clamp. I will show that in a second. Small, well, my large drill press wise, which other people call a grinding wise. Transfer blocks for the magnet, parallels, some vices. Usually my punch grinder sits here, not here currently. a magnetic angle plate, some 123 blocks or their metric equivalent, a small indicator stand. This is made by Compaq with a 10 micron indicator. I have more accurate indicators, but this often is way faster to use. Surface grinder wheels. I talked about my surface grinder wheel selection in another video. Let's look at this copal clamp because these are really nice. So these clamps, I think they are made in Germany. They have a cast brass body, worm drive back here, and then they have this forged arm, which is driven by this hex back here. And the way these are used, you have a T-nut with a screw in here. You slide this together like this. You don't need to bolt them down. You can bolt them down by opening them up all the way, and the wrench has a hex ball end here, and you can reach through the arm down here into the screw to adjust it or clamp it. But usually you just slide it where you need it. And you clamp like this. Extremely strong work holding. You can use them in pairs for milling. You can get riser blocks for them. You can get large long reach ones, different end pieces. These are just flat. You can get them with a V-block pad in front here. These swivel, by the way. You can get V-blocks. You can get a chain clamp version that uses a roller chain. Then there is a second block, and you can pull a chain around, for example, a large round piece like a pipe, pulling it into a V-block. Very versatile. I like it on a drill press very much, because on a drill press you often just slide it in place, align it, lock it, and you're good. This is way strong enough for drilling and tapping up to maybe 15 or 20 millimeters in a single pair. In a single pair, yes. In a single piece. So these are copal. Be aware, they are expensive. And I have my surface grinder here in the corner, the Bema FSM260, FSM260 with magnetic chuck. I'm playing around with dust extraction here. I have some blocks bolted to the side of the machine with a magnetic stand and some lock line holding a vacuum nozzle. I'm not crazy happy with the setup right now. Still working. I might just 3D print a regular dust extraction nozzle that goes in the back of the wheel. Might be more sensible. So yeah, that's the surface grinder. Purchased this about a little bit over a year ago. Got it delivered in February this year, and I'm using the heck out of it. It's a really nice machine. It's well built, very accurate. The roller guides and all axes are a very nice thing. The Heidenhain digital readout is insanely good. It's really a good machine. It's a very good fit for my style of work. It wouldn't be a good general use surface grinder if you were a tool and die shop. It's not a heavy duty grinder. You don't do hogging on it like Robin does on his Herrick grinder. This has only a 250 watt spindle. A very nice spindle that is, but not very powerful. It has limitations, like everything. Nothing is perfect. We talked about that. So again, there is a principle in my shop where I keep tooling that I need to operate machines close to the machine. The side of the shelf has, this is the extractor screw for changing the grinding wheels on this machine. The wrench, the wheel hub wrench. Keep a razor blade here to check wheel profiles. Steel rule, chip brush or grinding dust brush. Things like that guy, just pound in a nail and hang the thing and it's done. Very simple solution. Diamond dresser, some magnetic V-blocks, alcohol to clean the chuck. So yeah, that's the surface grinding corner basically. There is another one of these IKEA folding metal cabinets. This one has some hand tools and some accessories for surface grinding, also called a mess. These are just for the drill press to do polishing or cleaning. Well, it's almost an empty drawer. This is a squaring fixture. It's It's basically, this side goes on a magnet and then you can push work into this corner and it gets squared up in 2 axes by these screws. Bought this at a used machinery dealer. It's very nicely made. I guess it's shop made. It's highly precise. This is something which you would find in a tool and die shop usually. The dust jew for the CNC. Cylindrical grinding fixture and angle dresser for the surface grinder. I keep these in plastic bags to keep them from getting all dusted up. And down here is a project for the drill press. This is a foot switch and some cable. I will hook this up to the drill press at some point in time to realize a spindle reverse per foot switch for tapping. All our drill presses at work have a foot switch for reversing the spindle momentarily. And this is great for quick tapping when you don't want to set the depth stop for tapping. This is very, very nice, very fast. Requires some wiring. Currently I keep my vibratory tumbler here. Not the best place, not the worst place. When it runs it makes a little bit of noise. The problem is I don't have a sink here in the shop, so when I want to wash the stones I have to take the tub off and carry it inside and do it there. Not ideal. Also, this IKEA cabinet is a good place to store crap on it. Like the setup that I pulled from the milling machine because I needed it for something else. That's a rotary table with the punch grinder on top of it to do some manual 5-axis milling. Things like that happen here. I try something out and then I put it away and maybe never use it again and take it apart and do it somehow else. This is just the nature of the work I do, or the way I work. So, swinging on from the surface grinder, there is the heating. Yes, that's a problem. Heating surface grinder, that's a real problem. I have to be very aware of when I turn on the heating in here. More dyeing plants. Deckel FP1 milling machine model. This is a kit from a Japanese manufacturer. And this is a 3D printed Deckel FP3NC. Yeah, here is a close-up. Deckel FP1 with the high-speed head and the universal table. And here is the FP3NC, which would be a CNC mill. And with the head at an angle, milling a turd. Random bolt. Well, this is a M12 bolt, halfway sawn through. There is a story to that. I will tell that at some point in my life. Dirty fan, some battery charger for the camera. Good idea to change these. Yeah, it's great to charge batteries above a heater. Bosch cordless drill charger. And now we're slowly getting at a point in my shop where it gets messy. There is the Deckel S1 tool and cutter grinder. This machine constantly gets set up differently, as it's the nature of a tool and cutter grinder. You're constantly changing out equipment on it. But it's a really nice machine. I'm very glad to have it. I use it rather often. I have a step ladder in here because sometimes you need to reach up high. And behind the tool and cutter grinder there is some dead space and it just stuff goes in there. Not ideal. Well, tool and cutter grinder, not much to say. I keep the vise for it down here. Some tooling here. Not much to say. I talked about the S1 grinder extensively. Then there is more shelving. This currently is a little bit of everything. It keeps, for example, my electronic indicator, my Millitron. It contains the back relief attachment for the Deckel S1. I have sign plate, some additional S1 accessories, boxes with the taken apart dbit grinder. For example, up there is the motor for the dbit grinder. Here is the spindle, there are wheels, here is the grinding attachment, piles of collets for it. This is really a reasonable mess currently. So don't think that my shop is super organized all the time. It's not. These are, oh, I can show this. These are surface finish reference pieces. These give a reference on surface finish for different processes. This one is for drehen, which is turning. We can go from 3.2 all the way up to a RC surface roughness of 80 micron. You can see a 3.2 RC is pretty darn good. And a 80 micron, more like a washboard. You can hear that too, I guess. So these used to be really, really expensive if you buy them new. Got them for a steal off eBay. So we have turning, we have Flachschleifen, which is surface grinding. Yeah, this dates this quite well. The housings of these normals are made of polystyrene, and you're not supposed to clean the reference pieces with gasoline, trichloroethene, or acetone. The trichloroethene really dates this because we don't use that stuff anymore because you get terrible cancer off it. So you have surface grinding RC 0.4 micron all the way up to RC 10 micron, which is still a pretty nice finish. So turning, surface grinding, and this one is cylindrical grinding. This goes from 0.8 to 20 micron surface roughness. This would be really a bad surface finish for grinding. About 1.6 is what you would expect, for example, from some taper tooling for the taper shank of a collet chuck, for example. So that's something I keep around. Here is the rack of a dbit grinder that I own in parts. Since I last showed it, it has become green. I already made this plate back here and the additional moment arm here for the better controllable depth stop on grinding. I just need to find more time to work on it, but it's not dead yet. So this is another tooling cart that I keep around. This is also a dying piece because This used to have all the hand tools in here for running the dbit grind, the S1 tool and cutter grinder, when this was not a shop yet, when I only had the the S1 grinder in here. But since I moved my entire shop in here, I cannibalized this drawer because I put the tools back where they belong, and there's just some old crap left in here. I need to reorganize. There is the Morse Taper 4 tooling for the grinder and all the indexing discs. Accessories for dust extraction. Grinding wheels. Somehow, the second you acquire a tool and cutter grinder, you also acquire like a literal million grinding wheels for it. More grinding wheels. These are ID grinding wheels, a adjustable angle plate for the grinder, some random tooling that I either modify into other things or regrind. More tooling for the grinding spindle itself, like cup wheel, cutoff wheel, diamond wheels, tool holders, a chip brush. These are also ID grinding stones. And down here is a spare spindle, main spindle, the tooth rest to grind mills, the flutes of end mills, for example, tailstock, more little accessories, respirator, and the angle radius dresser. So this whole cabinet needs massive reorganization. Everything needs reorganization in here, to be honest. So just let's cover up the names on these sheets. This drawer or this cabinet used to be over in the manual department. I moved it over here because I was thinking that might be a good fit for here, and I don't hate it here. I have my hydraulic press on here that I mostly I built it for exactly one job that needed sheet metal forming in a die, and since then I rarely use it. I use it sometimes to straighten shafts, for example for drill press spindles. I use it sometimes for bending, and sometimes to just to remove or mount bearings. Indicator stand, I will get rid of this probably once I have the Tesa height in here. I will sell it off. Squareness comparator, this goes with the surface plate over there, but there is currently no space to have it. And the Schmidt arbor press. Also, I keep some lined up work on here. So this cabinet houses a lot of stuff. Also a mess. Some metrology in here. For example, ID mics from 6 all the way up to, I think this is, I should know this, up to 20 millimeters. These are excellent. I have the Quantum mic in here. I keep this away from the bench when I don't need it because I don't want it to get all banged up like the other stuff in here. Combination square. By the way, what's going on with Starrett tooling? I have really a lot of tooling from different manufacturers, but Starrett is the only tool that wants to rust on me. What's going on? I have the avid viewer might remember these. I made these in 2016. This is one of my small sine bars. I use this very often, to be honest. It's a really nice tool. 2-point internal micrometer, some knife edge squares. The Unimic, I made this too. I use this not very often. In all honesty, I don't use it very much, but when I need it, it's very useful. For example, to measure the distance of a slot to the end of a part. It was an extremely neat project. Learned a ton of it, and I would do a lot of things different, I think, today. Disc mic, machine level, universal protractor, a mirror super useful, a little bit larger than a dental mirror, just to see around things. Some precision ground flat stones. You will find these everywhere in my shop since I make them. Wow. Another drawer of mess. This is a pile of indicators. Most of these digital indicators are broken. There is a Mitutoyo Highcator, which is a 1 micron indicator. Here is the diacator. What you call it? It's a to center stuff on the mill, a centricator. Long series indicator. Well, with a dead battery as usual. A box with wedges. These are used to remove drill chucks from tapers. You use them in a pair around the tapered bob with the chuck on it, and then you just press it together in a vise, and it pops off the chuck without bending the arbor end. Means that you don't have to send the drill press spindle to me to fix it. Magnifiers. This is a depth gauge that I built. Uses a 25mm 1 micron Mitutoyo indicator. The base here is interchangeable. Again, I have a short one, I have a slightly longer one, and a extremely long one. And the extremely long one even can be mounted offset to the side for whatever that's necessary. These are made from Toolox, which is a pre-hardened tool steel, 44 Rockwell C. Then I sent it out for plasma nitriding. And then I surface ground and lapped the nitrided layer. And it's really not a terrible finish. They're very precise. Pocket scale, pocket scale, that's what it's called. Temperature sticks, these are crayons that change their color at a certain temperature. You use this to determine temperature of materials. For example, when you want to heat shrink bearings. Some micrometer heads. This is a digital or a contactless RPM meter. You put a piece of reflective material on a rotating part, then you hit it with this and it shows you the RPM. Very cheap, very useful. Here, another project. Precision Toolmaker's magnets. Surface ground on 4 sides to be square and parallel. Use them all the time. Super useful project, highly recommended. Hardness testing files, kind of useless these days because I have the hardness tester. That's what they called. Bore gauges, telescoping gauges, snap gauges, whichever name offends you the most, they are called that. They are made. They say Mitutoyo on them. They are made reasonably well. They could be a little bit smoother, to be honest. In the same vein, I have a set of small hole gauges. These are these split ball gauges that you expand by pulling this screw here, and they get larger and larger, and then you micrometer this diameter after you gauge the bore with it. Sometimes lifesaver. Also Mitutoyo. These are really nicely made. Some more. This is another micrometer head, some indicator holders. This is another style of center finding gadget on the milling machine. You put this in the spindle. You have a stylus down here and you can read it on the style here while it spins. Sip Hauser used to give these along when you purchased a jig grinder or jig borer. This is this is an exercise in cheapness. This is a endoscope camera for $7.99 off eBay. Sometimes useful to see inside of machines. Terrible image quality, but sometimes useful. So in here I keep collets from ER8, 11, 16, 20 and 25. I have a lot of collets. Larger reamers, larger drills, some spare collets, straight shank collet chucks, which I use, for example, on the mill as an extension or on the lathe in a tool holder to hold drills or taps. A small Tapmatic, reamers, more reamers, flat bottom drills, some carbide reamers, and these are drills that have been ground to a neutral cutting angle for brass. This way they don't get pulled into the material. As you can see, there is a tiny flat ground onto the main cutting edge, and that prevents the cutter from getting pulled into the material like a screw. So that's that. That drawer is working out rather well. This is some of the flat material storage. I have flat stock over here. Sealing paper, some plastic, some turkite, some sheet metal, some rubber stock, just a weird mix of materials. Brass shim stock, this is stainless. Shim stock in different thicknesses and widths. I have, for example, a roll of very wide 0.15 millimeter stainless shim stock. At some point I made some springs out of this stuff. This is all spring steel, mostly stainless spring steel. Some shim stock and some more shim stock. Also working out okay as a drawer. Screws. The only screws that I stock really are socket head cap screws metric. From M3 up to M8, from 6mm length to 40mm length on every size in between, and the according nuts and washers and fender washers. Also, I keep a box of M2 hardware here too. If I need something special, I will order it. That's the bitter reality, because this is the minimum of screws that I need and the maximum of screws that I can store. Working very well, this drawer. This is also a mixed ends drawer. Setup hardware for all the machines basically. I standardized on M8, M6 and M10 hardware. I'm mostly using M8 on the mill and the drill press. The M10 is for heavier work and the M6 is for very small kind of work. There are the strap clamps, washers, nuts and T-nuts. More shim stock and random crap out here. 5 seat blocks. Here we have this another project that I did. Well, this is going down memory lane here. These are the two rotary broaches that I built, and I use them. I use them a lot. They work very well and they are very nice. I would build them different now. I would not make them with a shank. I would machine the OD of them to a diameter that fits in a boring bar holder on the lathe. It would be much more stiff and easier to set up in the way I work. Most people would put them in the tailstock, of course. Rotary broaches for drilling a little bit larger holes. This is a fairly large tool for me, but sometimes it's nice to remove a lot of material in short order and keep the slug. Random stuff. This is accessories for my 3MOS height gauge. 3MOS height gauge is probably going away once the Tesa height comes in. Some larger hardware. This is, for example, I purchased when I set the milling machine, the Deckel FP1, on its feet. I needed some I think this is M16 hardware. Random larger screws. Bearings. These are just bearing rings. When I remove a bearing and it's scrap or I want to throw it away, I usually take the bearing apart and I keep the outer end in a race. They're very useful for spacers. needle bearings, axial needle bearings, angular contact, and radial bearings. I keep a little bit of stock usually at hand on bearings. Tapered roller bearings, axial ball bearings. Also not an ideal draw. Next one. This one is good. This works well. I have all my lapping supply here. Diamond compounds, some polishing wood. Back there is a little bit more polishing wood. A lap, cast iron lap, some silicon carbide lapping compounds. This is a boron nitride lapping compound, which is leaking a little bit. Very nice. Ugh. So this will live on a rack from now on. Well, this one won't because it doesn't fit anymore. Some OD and ID labs. Silicon carbide loose in a loose form. This is just silicon carbide grain. And back there we have a ton of different stones that I just cut them to size with a diamond wheel if I need to polish something internally. Then I keep my silver solder in here. And my accessories for my micro torch. This will not stay here because the micro torch is in the other room. These are polishing compounds from 5. This is fine, medium, and coarse. 5 to 8 micron, 10 to 15 micron, and 30 to 50. I keep them in a little box with the polishing compound. Some shank-mounted polishing felt bobs. And a little can of the polishing compound where I can, for example, dip a polishing wood into. Made these out of cardboard and hot glue. This works very well. It looks stupid, but it's very useful. You can take this, for example, over to the lathe and do your little bit of polishing and bring it back and be clean. Ah! A empty drawer. I didn't know about this. This is not going to stay here. 5C collet set for the lathe. Since I moved it over here, this is too far away from the lathe. Magnetic chuck, my small sheet metal bender and shear. I have a honking pipe center, life center for pipes. So that's the most boring part, the CNC router. It's doing CNC router work, nothing else. Built this from a kit, built it as good as possible, and it's doing as good as possible work for me. I do a lot of sheet stock on it, stainless steel. I cut hardened spring steel on it, for example, leaf springs and stuff like that. A lot of plastic and aluminium work. It's a workhorse. It's really not a very glamorous machine, but it works and it pays the bills. And it paid for itself numerous times. That's the most important part. 25k RPM spindle with 2.2 kilowatts. It has a spray mister. Usually I run either alcohol or just water-soluble coolant. It's running on adding CNC control. I have the wireless pendant here. It just works. I don't have a full enclosure. It's open topped because I don't usually cut dusty materials, and if I do, I can run dust extraction. And it doesn't really have a front. I just have a piece of Lexan that I can put in here in the T-slot to close off the front of the machine if I have a longer running job. So that's that. Let's move on. So if we zoom out a little bit and look back there, we have on the left side is the CAD/CAM PC work area, and over here we have all the support equipment and another window. So I have a hardness tester here my vertical bandsaw, which used to be a horizontal 4x6 bandsaw, but bugger the horizontal function, I need a vertical bandsaw. So I removed everything and made it vertical. The small belt grinder down here, diamond lapping machine, parts washer box with the brush, and ultrasonic cleaner. This is very important in here. I use it a lot. So let's move the camera back there. So back here is I have a PC. This runs, is a Windows 10 PC. It's really nothing spectacular. It runs both CAD/CAM and also the control software for the CNC, which is very nice because I can very quickly iterate between different versions on a CAM program. And I can program and run the machine at the same time still. Obviously, I like Star Trek. I have an old medical cabinet here that's just housing some of the stuff that should not get as dusty as other things like my camera lens. Geiger counter up there. This is built from a Mighty Ohm kit. Highly recommended little project. I keep end mills down here, my toolmaker's microscope. And this place is always a little bit of a mess because I'm not only doing programming and CAD/CAM work, I'm also doing some of my quoting here. I write notes, I do documentation, and it's a workplace. It's a workbench basically with a PC. So that's that. And we do a swivel to the right from the window, and we have the hardness tester. I keep some wood saws and my two regular construction levels, and this is a 2 meter long construction level back here, just because I don't have a better place for them. Hardness tester, demagnetizer. Keep a rag on it to keep the top plate clean, and also when you demagnetize something, you put it on the rag and you move it across the platter of the demagnetizer instead of sliding it across the steel plate, which will scratch the part that you demagnetize. So standard practice is just to keep a rag on it. There is one of those parachute bags or whatever they are called. I keep a little bit of electrician tooling in here, like wire stripper, ferrule crimper, multimeter, spade connector crimper, some screwdrivers. This is basically my go bag for electrician work. There's also there are, again, a bunch of these in here, Vago clamps to do wiring. That's just my go bag, some pliers. Neat little package. I have a little bit more electrician tools, but that's what that helps me to do about 95% here in the shop or in the house. Also, I keep my Gordon Freeman crowbar up there in case there is a head crab. So, material storage. My small diameter stock up to 1 meter length goes in these. These are 40mm PVC pipes bolted against 2 strips of wood bolted against the wall. And I label every piece of material that I have, either with the label maker, by engraving with a die grinder, or by stamping the material type into the end of the bar. Very important to know what you have. Otherwise, if you don't know what it is, you can throw it away, basically, if you do customer work. For personal projects, sometimes you need a steel and not 2210 drill rod or A2 tool steel. So, but it's really good practice to know what you have. I keep just some crap down here. There is I have material in every corner of the shop, really. There is some of the larger diameter stock, Also some oddballs like this huge ass piece of U-channel. All marked and labeled again. This drawer cabinet has machine manuals, like this is from the Deckel FP1. There is also the manuals for the harness tester in here. This is CNC accessories, some fixture plates, and some clamp hardware. There is a small vacuum chuck with a venturi valve, so it doesn't need a separate harness. So it doesn't need a separate vacuum pump. We have accessories for the harness tester. This is a large platter for holding larger parts to do testing on. More harness tester accessories, like in here we have the harness reference plates, for example. Back here is the paint off the harness tester to fix little damages in the paint job. A replacement indicator. In this drawer I also keep the grease gun and the grease for the CNC, and a spare stepper driver and motor. Down here, very odd place, I keep the Harding style 5C indexer and one of those cheap 5C spin fixtures and some angle plate stuff. But then we have, well, this is a piece of Delrin. We have the cabinet with the bandsaw on it. This is the 4x6 bandsaw when you remove the base, bolt it onto a small cabinet and add a solid 8mm thick steel table. This makes it a very capable small bandsaw. I cut steel that thick on it. The magic trick to these bandsaws is to put a as coarse as possible bandsaw blade on it. I usually run a 6 to 8 tooth bimetal blade on it. That's the coarsest blade you can get in the size. Works extremely well. I have it running off a VFD so I can change the speed. Very slow. Or a little bit faster. So that's the bandsaw. And the bandsaw cabinet itself would be a little bit tippy that high if you don't put about 300 kilograms of material down there. This stores material up to almost 300mm length. Again, with the pipe organizing system, that works very well for me. And as you can see, all the material is somehow marked what it is. We have 14305, diameter 22. So I know this is a piece of stainless, hence the number 14305 and 22mm diameter. So I don't have to search very long. Or a piece of 14305, diameter 30, and so on and so on. Further down I have some boxes with some cutoffs, but even the cutoffs, if you look here, are marked. Aluminum AV 6082, diameter 35. I don't mark the diameter on every piece, only when I feel very ambitious. There is a piece, this is a half-finished piece. This could have became a impeller wheel for a Honda motorcycle. This is also 6082 aluminum, so I know what it is, I can use it. Down here I have a chunk of aluminum, 2007 aluminum, diameter 50. So try to keep your material organized and you will be a happy person. I also, small shop problems. Sheet stock is a pain to store, so basically I push sheet stock in every slot between shelves where possible. Some aluminum here, some PVC stock over here, a large chunk of aluminum that doesn't find a better place. There is some FR4 epoxy sheet stock here, just random materials. So what I really want to show is that despite this place being extremely small, I keep a ton of stuff around here and still keep it in a condition that I can find something. This is all support equipment. The small belt grinder, this one tends to rust a little bit on the platter. I did a rebuild, I purchased it and then I did a full modification on it. And this showed me that I like a belt grinder in the shop. And at some point in time I want a bigger, like a knife maker belt grinder, and it will go here. The small diamond lapping machine, this I use all the time. I wouldn't build it that way anymore. I wouldn't hook up the platter directly to the motor. I would put this on a separate headstock and drive it with a belt, because the run out axially is a little bit annoying. Also, the drive pins are not necessary, and the magnets are annoying because the magnets attract steel chips all the time, and yada yada yada. Not ideal. It's a learning experience in here. Apart from that, real nice. If I did the table again, I would make the table wrap around the wheel, because you're mostly working on this side, and this side means I'm constantly using a piece of steel plate hanging off the side, C-clamped on here. Not ideal. What's this called? Ultrasonic cleaner. Use it all the time. Most parts that I send out need to be reasonable clean, and the ultrasonic cleaner is doing a very good job of it. The wash box back here is more for shop tooling that needs to be cleaned. So we are not finished here. We can look up, look up, look up, look up. This is almost comical now. A friend sent me an eBay link to a seller that was selling a set of gauge pins. Well, gauge pins, everybody has gauge pins, but most people don't have a full set of gauge pins from 0.8 to 15.6 millimeters in 10 micron increments. This is almost comical how many gauge pins these are. This is a full set of gauge pins in 0.01 millimeter increment, and I paid less for it than for a single box of them if you purchase them new. And they are in perfect condition. This was really the purchase of the year. Really nice seller. These came out of a calibration lab that closed down, and he purchased a ton of equipment of them, and the set of gauge pins was part of it. So gauge pins are really nice to gauge holes. It's that simple. And having them in 10 micron increments is even more simple. I keep a depth micrometer here and a 300 millimeter Mitutoyo dial indicator. A stack of shop rags. I purchased like 30 or 40 of these rags. And I have a separate washing machine only for shop clothes and rags. It's basically our old washing machine that I kept around. And I wash them, I cycle them through. I wash them, I put them in the dryer, and then they go back in the shop. It's cheaper than buying a ton of shop towel. For some reason I have a corded power drill here. A smaller set of gauge pins from 0.5 to 4 millimeters in 50 micron increments, and a lab power supply that I use all the time to drive different things. For example, the cylinder grinding fixture. So let's look at one of those boxes of the gauge pins, because that's really awesome. So some of these boxes are a little bit damaged. This one needs some severe repair on the hardware, but that's not really a problem. So this is really a box with pins from 6.8 to 7.8 millimeters. This is a little bit of a strange stepping. Usually, so these sets are always from 0.8 to 0.79. They range 1 millimeter across from here to here. And you have them in your little small increments. So really nice to work with when you do a lot of small parts like I do. The only drawback to them is how much space they eat up. This would be half of a Lister cabinet, basically. But to be honest, it's worth it. That's why I put the shelf up there and put them on the wall, so they are kind of out of the way. It makes the room a little bit like a cave by this overhang, but that's okay. And yes, this still opens. This is the overhead hatch to the crawl space over the shop. Crawl space is just for storing, for deep storage. You almost made it through this shop tour by now. I think this is the last cabinet that we're gonna open up. So this contains, do you remember this project? This is the adjustable angle table that I did a full rebuild once I purchased it. Works very well. Accessories for my indexing heads and the dividing plates for the rotary table. Usually the rotary table sits in here. Some more dividing plates for the larger indexing head. This is the Walter UTA indexing head. The Sanu 6-jaw tool grinding chuck. The chamfering machine, I don't have a dedicated spot for it. When I want to use it, I just take it out and clamp it to the table of the drill press. This box here, this is the Moore setup block set, but I took the blocks out because they were more useful when they were out. Down here, same thing as with the shop rags. I purchased a ton of microfiber rags, and I do the same. I use them in the shop and I wash them and dryer them. And down here, this is a future project that I kept around for many years. This is a Moore centering microscope of a Moore number 3 chick grinder. Need to remove the back plate here and make a shank for it so I can use it in the milling machine. So that's that. There we go. Oh yeah, and that's something that I'm constantly pushing from one corner in the other. The Festool dust extractor with the cyclone separator on top. It's always in the way, but absolutely necessary in a shop. So that's the CNC department of my shop. I hope I didn't bore you to death with the way I organize my shop. I hope this is inspiration to some of you, how you can put a ton of stuff in a fairly small space. So for those asking, my shop is 25 square meters in total. That's 270 square feet. I don't know in the grand scheme of things if this is a large or a small home shop, but you can do a lot with this amount of area. As you can see, I push in a full manual machine shop with a mill and a lathe and a surface grinder and tool and cutter grinder and a drill press and a dbit grinder and support equipment, and also a CNC mill and place for metrology, like a surface plate. So yeah, that's my shop. And keep in mind, I use this shop to earn money. So that's the reason why I have so many things in here, and very deliberate things. Also, I have this 6-month rule. When I use something not for 6 months, it probably doesn't need to stay in the shop. I can take it and put it either in deep storage or get completely rid of it. Speaking of things, down here, well, there is a box in the way. Back there, behind the CNC controller, there is a Moore rotary table on a rolling cart. Rolling carts are your best friend if you want to move heavy equipment out of the way. And down here, below this, below the CNC mill, I have the overarm support for the Deckel FP1, and the overarm support and tailstock for the indexing head of the FP1. So every corner and every spot gets used in here. I don't have much wasted space, to be honest, or at least I hope. Case of water. Back there, the PC, and above it is the 3D model of the shop, the cardboard model with the 3D printed machines. I still use that from time to time to play around with the layout. So, against all odds, you made it to the end of this video. So, this was really a horrible long shop tour. If you hang on that long, I wish you all a great 2023. Well, I wish you a great 2023 too, even if you have not watched all the way through the shop tour. I fully can understand if you don't want to commit that many hours me rambling on about the stuff in my shop. So thank you all for watching, and I'll be back next year.